First of all, I want to thank everyone here for their amazing talks. Now it's my job not to do even better and try to keep this quality amazing. And I want to reflect back on what Igor was saying earlier, that the mission and the goal of this conference. And I experienced this firsthand because when I saw the quality of the review that I got, I was happily surprised. And me speaking of this because I've been submitting to a lot of conferences, and I can see the quality of this review is matching, what people would classify as A and A star conferences, right? And maybe it should not be the surprise, but it was surprising me because it's not should be surprised because these are people who do quality, right? So of course it's in their genes and their blood to deliver quality review, and that's why I have to also deliver this kind of a quality presentation where I'm trying to avoid maybe going into many details and technical stuff, because this is what the community, the community, they knows that, but they want to see more of reflections, things that they want to care about, things that they should learn about, right? So I'll try to have that type of reflection, and it will be kind of a storytelling. I know we're out of time, but I'll try to keep myself on track. So let me give you the story behind this work. So the story all started when one of my students, Hussein, came to me back when he was working in Xerox. Now he's in Microsoft, and he said to me that he noticed whenever he does a refactoring pull request, it would take longer than the other pull request to be approved. And obviously, he was doing this to trigger me because I'm a quality guy, and we always teach that refactoring is the art of improving software quality without changing its behavior. So you'll be expecting that this would not be the norm, right? You'd expect people to quickly approve refactorings versus maybe other types of changes, such as features or bug fixes, right? So I wanted to really see the bottom of this and see whether this is true or not. So we tried to contact, Xerox. We end up spending some few months trying to get those NDAs signed up and everything, so we can get some access to some data, right? And we did. So we get on the year of 2019 when we did this experiment, we picked 171 refactoring pull requests. So by refactoring, I mean developers are intentionally doing this pull request or this code change to improve the structure of the code. Okay, this is what they outline. We picked who did these authors. We picked similar 171 non-refactoring pull requests from the same authors on the same time, on the same code, right? And we compare them from 2 dimensions. First is how long it takes reviewers to make a decision whether to approve or reject that code change, and how long is the discussion happening in terms of discussions when it happens between the reviewers and the co-authors, right? And this will allow me to see whether what my student have observed makes sense or not. And surprisingly, it was the case. So we did notice that the refactoring review takes longer to be approved or denied than the non-refactoring pull requests. And also the number of discussion or the messages discussed, the exchange between authors and reviewers takes longer, right? And this is why we decided to maybe come up with a checklist for code authors to sort of help them do or document better their refactoring, because part of this problem was how they express their refactoring, right? And this is where you realize that when we are talking about bug fixes, we are sort of mature on how we can document that, right? Or features, right? But how do we document refactoring? That was the problem, right? And we come up with this checklist where we call this the 3 I's, right? So when you are documenting a refactoring, you may want to think about 3 things. Number 1 is the intent. Tell us what is about. What is your refactoring here? Are you removing duplicate code? Are you removing dead code? So what's exactly the reason about this, right? So it's the intent. Then tell us what are the instructions. You're renaming, extracting, inlining, pushing, pulling. What are you exactly doing in the source code, right? And then give us how can we evaluate that? Is the impact. Are you improving readability? Are you improving coupling, cohesion? Tell us how do we evaluate your code so we can take that as a part, right? So this was our checklist, and obviously this recommendation went through, and they were started using it. But I think as I was doing this experiment, I realized something bigger, right? So if you walk through the streets of France, you'll find those railroads, and you'll find this sign was written in French here. I'm wondering if anyone can read this here, but I can help you with this. Is this saying that one train may hide another one, right? So I think this problem with the refactoring documentation is actually hiding a bigger problem that exists in our literature review. Actually, we've been talking about misuse of refactoring. We're talking about people not trusting refactoring. So you don't have to read all these papers. I can summarize them for you. They were saying that refactoring tools are underused. They're talking about people still doing things manually, and they're talking about people not knowing how to document their refactoring. And I have just given you one example of that, right? So we are basically suffering from a lack of refactoring culture, right? So this is the clear thing. So one of the papers that talking about these problems, right? They mentioned that one of the typical IDEs that trigger people to do refactoring was IntelliJ. Okay, and this is how we got interested to actually collaborate with JetBrains Research to sort of come up with an answer to one question that I always had in mind, right? So, I mean, if you want to know how to improve instead of refactoring, you have to know how developers actually refactor their code first, right? What triggers them to do those changes, right? So what we have done is, with collaboration with JetBrains, we were able to get access to over 1,000 developers. Many of them, they are actually experienced. They do, they code, they work in different companies, right? And we were asking them a lot of questions that we're going to just give you one question here, which is how the code gets refactored in IntelliJ. And we gathered a lot of answers, and I'm going to just put them in one nice heat map here, right? So when it comes to refactoring their code, we're going to cluster the refactorings into 3 families, right? The rename, the extract, and the move stuff. When it comes to renaming stuff in code, actually developers do use the IDE to do that, which is good news. Why? Because when you use the IDE, you are sort of guaranteed not to introduce regression in your system, right? But when it comes to extracting things, which is sort of a complex operation, right? Only 50% of developers would use the IDE for that. The others, they would take the risk of doing things manually, right? Even worse, when it comes to moving things, we are still doing the tradition of just copy and pasting code, right? And this, to me, was found to be alarming, right? Because we have a lot of operations that we know how we should do them, but we are actually still using the manual fashion to do that, right? And this brings another challenge here, right? Which is obviously technical debt, right? We all know that we are overloading our software with a lot of features, just like we overload our cars and our products whenever we can. And this, of course, comes with a cost, right? No questions about it, right? And if this is the challenge, then the answer or the recommendation should be this menu, right, on the IDE, where people can really refactor their code, and we offer all these features to them, right, to do that and improve the quality of the software. But this menu, from what we have seen, is underused. And maybe the next question would be why this is even underused, right? What developers then, when they're refactoring, what do they even care about, right? And this brings my next question, and then I'm just borrowing from Dave earlier, right? Which is, what are the illities that developers mention when they document their refactorings, right? So Dave talked about the 70s, people talk about those aspects, right? And then in the 80s, people talk about these aspects. What about nowadays? Well, we as researchers, we like to do this top-down type of thing. We think this is what developers should think about. This is what we think they should think about. Instead, I've done something which is bottom-up. Instead of doing that, I decided to look at a lot of commits, right? So we looked at 3,000 projects over almost 3,700. Sorry, this is she's going. So we looked at 3,700 projects where we had over 300,000 commits with refactoring happening on them, and over 1 million operations. And we looked at how developers document that. What are the keywords they use to justify their refactoring, right? And we come up with this table, right? This is 2019. So this table sort of shows the illities that developers are documenting in their changes, okay? And we kind of classify them into internal, external, code smell, and obviously there's a lot of keywords here that are familiar to you, right? So like some of them are literature, some of them are interestingly there, and we sort of start looking at them to sort of come up with better ways to refactor their code, or maybe to incite the IDEs to care about these things, because that's what the developers are caring about when they're refactoring their code, right? Which is obviously duplicate code, dead code, and we started working on that in a different story. But today's story comes also bound to this performance thing, right? So why developers refactoring for that, right? So this is, for me, was a little bit surprising. But at the same time, I looked at it and I said, let's take a look at this deeper, right? So performance regression, and we all know that, is when you're introducing a change in your source code, which may be correct from a syntactical perspective, semantic perspective, but at some point of time, when you run your project, now it runs slower, okay? Well, the word regression can go either way, but 90% of developers, when they say regression, they mean the negative aspect, which is, slower in execution, right? And those changes are interesting because it can happen in so many ways, right? If you take this example, where us moving from a vector to a data structure, which is obviously something that we teach our students to do, use data structures because they are better, they offer a lot of functionalities for you, and you can, it's called reusable. And from a quality perspective, this is maybe a better code, right? But this type of change actually introduces performance regression, okay? And this makes you question now the quality aspects of it, right? So if we are pushing for better quality and we are losing from the other aspects, so we sort of maybe have some kind of a contradiction or a conflict, right? So I want to ask maybe myself, okay, so if this is really a problem, but we have already an armada of testing tools to prevent that from happening, right? We have mutation testing. We just saw Randy talk about this right earlier. We have a lot of people who work on performance regression. They can give you a lot of benchmarks to actually help us with this. So maybe this is not really a problem anymore. But if you take a look at deeper how this is happening, it's actually bigger than we think, right? So if you take the example from this Git repository, right? And if I look at two versions of Git, this is 2018, I think. If you want to move from version this one 221 to version 210, right? It will take you around this much of commits to test to make sure that there is no performance regression introduced. So you have it's a period of maybe like a month and a half or two. Yeah, it's like almost a month and a half, 45 days, right? They wrote this many commits in there. So the best way to guarantee the absence of performance regression is to just test every single commit, right? So let's do that, right? To do that, we have to actually test this code with 5 benchmarks. Those benchmarks would take around 2 hours to run, right? Each. And this will result into 37 days of testing. So to test 45 days of coding, we need more 70 days. We will need 37 days of just testing, right? So it's actually a bigger problem than we think. So testing could be an answer, but not nowadays. We need definitely better ways to do that, right? So therefore, we thought of understanding what is exactly happening with performance, right? And to do that, we have to start looking again at developers, what they complain about, right? We thought about this is maybe the best way to look at that is where people are complaining, and this is Stack Overflow. So we did this analysis to sort of come up with, I'm not going to go into details again, because you can find all these details in the paper, but here you can look at what we have done to kind of classify what are the types of problems associated with performance regression that developers are complaining about on Stack Overflow. And this boils down to this nice chart where people talk about algorithmic issues, right? Someone switched from an algorithm to another, and now they are experiencing this performance regression. People talk about APIs, right? People talk about environment, right? And if you look at the frequency, then obviously APIs are getting the lion's share of introducing performance regression in the systems. And this is all sort of interesting because we do teach also our students to use APIs from the purpose of reusability. It's like the whole purpose of reusability is to use APIs to save you some time. But this also coming up with its own counter expense of increasing performance regression. Also the environment, which is sort of outside of our control, because when you switch from one environment to another, you deal with all these inconsistencies and the different architectures. And this is, of course, what has its own performance regression, and then also algorithms, right? And to show you that this is really a problem for them, developers as well, is because when you compare the time to find an answer and on Stack Overflow between performance-related questions and Java-related questions in general or Android, right? Performance, they take longer to be answered in general. So it's not a trivial type of question that we're asking, and we don't really get people to answer it very easily, right? And if you look at deeper into the levels, right, we get a lot of questions that are actually unanswered, right? So it's, and this is another problem too here. So it's half of them almost, you may not even get an answer at all for these questions. And this shows you the problem of that we are facing here, right? And this builds to my reflection as someone who cares about quality, is that we saw earlier that developers are trying to refactor for performance, right? But what I came up to conclude here is that performance is deeper than just refactoring. It's all about reusability, APIs, environments, algorithmic design decisions. It's all about software engineering practices. That's why it's more problematic than just refactoring. Thank you so much.
I have maybe not directly a question, but a comment, because I'm also, as a software developer, I tried to do what you suggested, to check the performance on each commit. And aside from the problem you mentioned, which the time which is required to do the proper performance testing, the second problem is that the results you get may be very different from the results you get on the previous testing, and there are many factors which affect your results. Even though you may not, downgrade the performance, but the results may be so much different that your CI will raise a red flag. It will say like, look, your performance is going down, even though it's not going down, but just the situation is different. It's a different workload on the machine. The machine looks different, or whatever, many factors. And maybe this is another reason why people don't do that, at least why I don't do that. And I don't know the answer to this. So what do you think could be the answer? Or I don't know, or it's still another challenge?
I mean, for me, I realized that it's a bigger problem than, I mean, from my perspective was that, is refactoring an answer to this problem? The answer here was not really. It's a deeper problem than just refactoring. This is what I realized, right? And to me, yes, what you mentioned here fits sometimes into the environment, right? It fits into the machines that we're using, the workload. So what we need here is, and maybe also Randy can pitch in here because he's more testing than I do, this guy. So we need to kind of, because from a refactoring perspective, we do have a uniform understanding of how refactoring is performed, and with pre and post conditions and everything. But in testing, I did not see the same kind of culture here, right? So Randy, what do you want to say about this? What do you think?
Well, actually, I was going to ask a question along those lines. I know in industry, I did my own unit testing, tried to test my own work, but I wasn't a tester per se. But my research is in testing, and I like testing. But I know in industry, especially the more large the system is, especially my last few years in industry, I worked for the government, government system. So changes do impact testing, but as a developer, I always wanted to, as I moved through something, I was always tweaking this and that, trying to clean it up, refactor the code smells and whatever. And that was really strongly discouraged in my last few years in industry. And I do understand that if you change the code, in theory, it should be tested. But if you're doing regression testing or unit testing or in a release environment, those problems should be caught anyway. Anyway, I'm babbling a little bit. My question was, is there research that could support the notion that refactoring continuously is actually good and not detrimental? Are you aware of anything like that? Something to make the case for refactoring on all the time instead of just periodically? Or
okay, Randy. So I'm going to answer your question, and I'll go back to Igor's question. Because I do have maybe an answer for that too. So to answer your question is, at least the research that I do with JetBrains is we are trying to go from that periodic type of refactoring into something more interactive. So instead of us asking developers to do changes then refactor their code, why don't we instead detect refactoring opportunities as developers are coding, right? So we have to understand the context of the development to sort of say, hey, you just created the duplicate code, and I think this is worth refactoring. Do you want to do that, right? And we can add that, warning to say, hey, refactor this if you want, right? If we want to do that, then we have to understand the context. When it comes to understanding the context, deep learning is good at that. So that's what we start doing right now. We started using deep learning and potentially language models to detect immediately when there is a refactoring opportunities to happen, because if you can recommend it on the right time, maybe developers will give it a shot. So that's what we're doing right now. We are developing plugins as we speak, to actually do that work, and this will be tested soon. This perhaps maybe answers, hopefully, Randy, this answers your question. And so this is, and as you can see here, deep learning was used just because it's good at detecting the context, and it can tell us quickly, right, whether this is worth refactoring or not. And this also can be used to answer Igor's question, because what we have tried recently is to look at the history of code. We do have a lot of cases where developers experienced regression. So we can take all these code changes, and we know that this code change and what happens this way induces performance, degrades the performance. And we have a lot of other code changes that did not do that. So we have a family of bad people, bad code, and good code. So this would be a perfect match for a binary classification problem for machine learning, right? So if we can come up with ways to find the features and the patterns that exist into those type of changes, and if we have a new piece of code that is written and submitted, is this piece of code closer to the bad code or closer to the good code? Maybe if it's closer to the bad code, we said, hey, be careful. This change has patterns that has been known to reduce performance. You want to test that. So we are kind of trying to come up with test case prioritization type of technique using this solution. And maybe this will help us not testing every piece of code instead, right?
Sergey, you want to say something?
Yeah, I have maybe one comment and one question. The comment is that actually, from the point of view of deep learning models and large language models, one of the currently very challenging thing is actually the getting the context. That's important, and that's an issue in modern large language models to correctly get the context. So there is no exact solution for that, and that's a challenging point just to mention. And the question, you've mentioned one important thing. When there are cases where the performance contradict other quality metrics. And yes, that's the case, because you can easily make a like a large code which performs better, but well, is less readable, for example. Did you analyze the Stack Overflow data and the issues in this aspect? Did you observe some challenges where, for example, the people ask questions on the performance and there is an answer on the performance, and there is another answer saying that's performance improvement is good, but it decreases something other? Is that the case?
It's a very great question, Sergey. So, well, in order for me to answer that question, I would have to have access to the source code. But in Stack Overflow, the source code is not always uniformly present the way it makes you really quickly do that. However, to answer your question, I did do that in a different context, because I do have access to these commits, right? So when developers are saying, for instance, I am trying to I'm just going to pick here something. I'm going here to reduce complexity, right? This is the line that I'm here pointing out, right? I can detect whether they have done that or not, because I have access to their source code and I have access to the ways to measure complexities, right? And coupling and cohesion. I can see whether this change has detrimental effect on other qualities instead or not. That I can do. And I kind of did the first part of it, where I look at whether when the developers say they want to reduce complexity, they do it or not. I mean, I'm not trying to question the developers. I'm trying to see whether we are measuring these measurements the same way developers think they're measuring it or not, right? Because your definition of complexity, my definition of complexity might be different, right? So I'm trying to see whether our tools that we have right now are measuring what developers perceive as an improvement in code. And I found that to be, it's one of my ESM papers on 19, and I found that for some measurements, it is the case, and for measures, it's not the case. It means, for example, for instance, when we talk about complexity and coupling, yes, it's matching exactly the measures. So whenever developers say, I'm improving coupling, I saw the decrease in coupling. That's true. But for things like polymorphism, design size, and inheritance, it was not the case. Why? I don't know. Whether it's developers don't know what they're doing, or we don't know how to measure that. It's a good question that I don't have an answer to right now.
Maybe one more small comment
Sure.
is that, for example, if we consider complexity, actually there are different complexities. One is in the code, and one is inside the developer, in the developer's brain. And,
actually, we even I didn't want to mention this, but we tested even multiple types of complexity, the cognitive, the cyclomatic. So we tried multiple things to see whether one of them at least matches, right? Because I know that people, commit messages are short. They don't mention everything, but at least I want to see whether there is a match or not. So I agree with you. They have their own definition of complexity, which is right, because they are the people who own the code, not us.
Yeah, you're right. There is no two complexities. There are two groups of complexities.
Yes, yes.
Mohamed, what do you think, what your intuition tells you, why people review pull requests longer when they understand that there's refactoring, but not new functionality being introduced?
Because they're doing their job and they want to check checkpoints, right? So they don't have a checkpoint for how they review refactoring, but they have a checkpoint for how to review a bug fix.
But
so it becomes very subjective, Igor. When you talk about how to improve, how to measure the impact of refactoring, we will be subjective in this topic. But if we want to test whether a fault is fixed or not, we will be all doing the same type of practice. I think this is the reason why.
But could there be a connection between two facts you gave us today? First of all, you said that people don't use tools as much as they could for the refactoring. So they do a lot of refactoring manually. And I, as a programmer, can confirm that fact. I agree with the data you received from JetBrains that yes, indeed, when I want to move some piece of code to another class, to another file, I do it manually. I don't click the button. But if I want to rename something, yes, indeed, I click the button. So that's a true data. I totally agree with these numbers. So this is the first fact you gave us. The second fact, you said that, look, people, when I submit the pull request and inside the pull request, there's refactoring, people spend more time. So they get suspicious. They don't trust me. So first, I don't use the tools. Second, people spend more time because they don't trust my code. Maybe there is a connection.
Yes, totally. These are connected facts, right? And the question becomes, where do we start to fix that? Should we start asking them to automate so that we can show how this is working, or we should instead educate them on how they can document probably their changes, even if they are manual, right? And this is where right now, as us, researchers, at least with the collaborators that I have, we're trying to see how can we, because we've been writing automated tools for refactoring for the past decade, by the way. It's not like something we're not doing already. Just like a lot of tools that we have in research, but they are not really adopted in practice. And the question is why, right? Why? If you want to do all these refactorings, we can do them automatically. We can even have tools that can tell you this is a code smell and fix it, and they can fix it for you, right? We do have these tools. Are they used? No. Are these tools useful? Of course they are. So the question becomes where to start. Should we educate people about these tools, or should we keep trying to inject these tools in their workload without, making them more invisible and transparent, and just let them use it without even them knowing? Is this the way to do it? I don't know. This is where we're trying to investigate here. And this new plugin that we are developing, it's actually calling these refactoring IDEs behind the scenes and telling them, hey, look, we can do this for you. Do you want to accept this, right? Instead of this telling us, hey, go and fix this dead code later after you finish your code, right?
I just want to add, maybe there is a question about the cost of doing things and the cost of failing with things. Like, for example, in renaming, you can easily miss some mentioning of a variable somewhere in the large code. When you move the codes from a point to point, actually, usually you move a large piece of code and there's no place to make an error. Maybe we can measure this balance and provide some score or maybe value of the refactoring functionality and IDE. How do you think?
I totally agree with you. So if we come up with a gamification of refactoring where we can give a score to your code before and after the change, right, from a non-functional perspective, right, maybe this will incite developers to now look at this number and start and it's not even improving it, but get familiar with the aspect of it, right? So they realize, okay, how this number works, right? Because right now, all what they know is pass fail. Am I passing this code or not, right? Pass fail, right? This is all what they care about, But if we give them a score of quality score, right, regardless of whether it passes or fails, right, this will help them and educate them to think about how this number is generated, right? And this number is looking at whether this code is cohesive or not, and whether this name, they make sense or not, right? I know in some companies, they do have tools to detect that and not even let that pass. I know that when I talk to some collaborators, they have, but these are really very few companies that are well established. But the mainstream developers don't have that luxury anymore, right? But we do have tools, and we should do that. We should start educating developers more through injecting better, refactoring tools and make them more transparent in their IDEs. And this is the perception that we have right now with JetBrains, and I hope we can be successful in doing that.
Okay, and we hope that when you have the answers, you come back to us next year and with your new paper and show us some results which you obtained.
Sure, I hope so. Yeah.
Okay.
Thank you so
All right.
much. Thank you.